Hello everyone. Am I live? Yeah, I am live, and the stream is starting soon. Thank you so much for coming live. I've never done this before, and it's a good challenge. Going to try to do some bit of data cleaning using Kaggle data. I've not interacted with this data, so it's going to be kind of a roller coaster. But if you're here to see tricks in data science, that is filtered, then you're in the wrong place. But if you want to see how we learn data science, we do stuff in data science and mostly data cleaning, yeah, you're in the right place. So you can go to the charts. I think I should open my charts somewhere here so that I can see and comment. But I'll be reading your comments. I'll be checking into your suggestions. Um, and yeah, so I'm going to go to the data set. Remember, the data set was where? Let me find the data set. I'm posing which data set do you want to work on? It was HR data. So I searched for data cleaning, and I want to work with this HR case analytics data today, just for fun, for fun. So let's read. Let us read the description. You can't just jump into the data without knowing what it's all about. So I'm getting the data from Kaggle, guys. Don't don't um, don't cancel me because I'm not giving you credit. Kaggle guys, if you want me to market you, you can hit me up. But I'm getting data from Kaggle, and I just want to play with it and see if it's it can improve our skills. We shall do lots of googling. I don't have the whole knowledge on my head, but knowledge is online. What we know is problem solving. We are data scientists and we're problem solvers. So the problem statement here is HR analytics, case study, employee attrition analysis. This is nice. Okay, cool. Employee and attrition. That is people who leave work, people who are fired, people who resign. Yeah, yeah. Kind of where I work here. It's good to do this analysis. So let's start here and see how far we can go with this data. So the problem statement says a large company named XYZ employs at any given point in time around 4,000 employees. However, every year around 15% of its employees leave the company and needs to be replaced with the talent pool available in the job market. The management believes that this level of attrition, employees leaving either on their own or because they got fired, is bad for the company because of the following reason. One, the former employees' projects get delayed, which makes it difficult to meet timelines, resulting in a reputation loss among customers and partners. A sizable department has to be maintained for the purpose of recruiting new talent. More often than not, the new employees have to be retained for the job or given time to acclimatize themselves in the company. Yeah, this is true. Hence, the management has contracted the HR analytics firm to understand what factors they should focus on in order to curb attrition. In other words, they want to know what changes they should make to their workspace in order to get most of their employees to stay. Also, they want to know which of the variables is most important and needs to be addressed right away. Since you are one of the star analysts, star analysts, the way they praise us, eh? um, by the way, do I have viewership? Does it matter? You can still be online. So they're saying that Since you are one of the star analysts at the firm, this project has been given to you. The goal of the case study, you're required to model the probability of attrition using a logistic regression. Nice. The results thus obtained will be used by management to understand. I hope you're not hearing that noise. I don't know. People are working on Saturday. I thought you are required to model probability of attrition using logistic regression. The results obtained will be used by the management to understand what changes they should make to their projects in order to get the most out of the employees. Right. So that is the problem. People are leaving. They want us to get the probability of someone leaving and what variables are most important to address this right away. And we are the star analysts. So first things first, for any project that I usually do, I create, let me first check here, channel, it's live, I'm going to mute. Starting streaming. Just give me a second. I put this on my LinkedIn and I tell them that I'm live, so that they can join us and we have a greater discussion about this. But for the meantime, what we are going to do for this project one is to create a repository in I am live. Cleaning data. So the first thing you are going to do is to create a repository, GitHub repository. Then we are going to look into the data. I prefer downloading data, but it is more shareable data. This data is available for the public domain, so we can do anything with it we want. I'm going to create a repository for this. My repository is Danny Dalmas GitHub. GitHub. This is my GitHub account. I'm going to create a repository. I'm going to call it HR data. I think I should put a minus here. Data cleaning and analysis. Great. So it's a public repository. I'm going to add a git ignore, and I'm going to use Python, and I create this repository. So this repository is where we are going to be pushing our code. You can find this repository from my account in GitHub, Danny Dalmas, then HR Data Analytics Cleaning. Yeah, so let me continue. I'm going to clone this repository. So cloning, this is out. Where is my terminal? So here is my terminal, and I'm going to go to my documents, and I go to my personal stuff, and I'm going to clone it, git clone. I don't know if you can see this. Anyway, I'm just writing git clone, then I clone this. It is cloned. I can now go to the repository, HR data analysis, and this is what is in the repository. Nothing. It doesn't have even readme. I would have added a readme. Anyway, no problem. So we are going to start an environment. I need to make this bigger. Let me just go to the settings so that you can see. I don't know if you can see. It is not so clear. I'm going to make this big. How do I make font big in this thing? Window. Shell. Terminal preferences. Yeah. Okay. And I'm using Pro, so I'm going to it is text. Yeah, Monaco. Let me change this font size here. I'm going to make it. Let's play with 24. 24, right? There's nowhere you write save. 24. Good. How do I know that it is 20? It has gone big. I close this terminal, then I open it again. Yeah, it is now big and it's clear. Let me see how you're seeing it. Yeah, this is fine. So let's move to documents. Then my personal stuff. Then HR. Yeah. So we don't have anything. The first thing we're going to do is to create a virtual environment. So I'm using Python 3 minus m virtual environment dot n. So I'm creating a virtual environment minus m. Sorry, minus m. So the virtual environment will now package my project so that I don't have I don't set my environment in a conflicting way with the system that I have. So the next thing we're going to use the virtual environment source.n activate here, and then so we are going to install some stuff. I'm going to install I'm going to work with pandas. Pandas comes with NumPy inside it, so that's double installation. I'm going to work with Jupyter Lab. I'm going to work with PyCaret. I hope I will reach that level of using PyCaret. I'm going to work with Plotly. I'm not so familiar with Plotly, so I'm going to do a lot of Googling when I'm plotting charts. Yeah, so as this goes on, we are going to download this data. I like downloading it so that I can work with it offline. We understand now the problem statement and the rest of stuff. So I'm going to download this. So who is in chat? Who is in chat? No one. I'm seeing Okinyi-san. Thank you for supporting. I've seen Jonathan Chibazo. Thank you guys. Thank you. Let's continue. So this is installing. I've downloaded this. It's called Archive Zip 1. I'm going to look for it here in my downloads. Where are my downloads? Yep. So my downloads are here. You can't see it. This is still downloading, but you can't see my downloads. I can't show you my downloads. You want to see things that you've never seen. Archive 1. I'm going to copy archive 1 and I'm going to put it in that folder which is installing. So where's the folder? It's here. Personal, HR, paste or paste. Then I'm going to unzip, and voila, there we are. We are here. I have that is the data folder. I'm going to move this to trash. It's what I downloaded. I'm going to rename this, rename it to data. So the data is here. Let's inspect what's inside this data as we keep on installing. So we have data dictionary. Yeah, so let's read metadata before we look at that. License unknown, visibility public. That means it's available for the public. We can share. I don't know. I don't know if I can share, but I'll try to ignore in the git ignore that sharing capability so that I am not cancelled. Yeah. So logistic regression, HR case analysis. What I want is more of cleaning. So this data dictionary, it has unique values, age, attrition, business department, the meaning, the age of employee, attrition is, so this is where we can find what we don't understand. Yeah, I get it. Performance rating for last year. Relationship satisfaction. How do you determine relationship satisfaction? Is it them saying that I'm very satisfied or I'm not? Something like that. I don't know. Anyway, work-life balance. Do they follow them to their homes and see how they are balancing? Anyway, let's not question. We're not the ones who collected this data. Employee survey, data survey. Let me look. Who is here? Who is watching? Please, if you're watching, consider subscribing. You'll be doing me good, more good. Employee survey data. Oh, so this is their survey, and then this is employee ID number, the work environment satisfaction level. I think it is here, work environment satisfaction level. Do we have it? Work-life balance. You know what? How satisfied are you with your work environment, job environment level? Job environment, job involvement level, work-life balance. When we go to general data, what do we have? We have who is this taking my attention away? Yeah. So what do we have here in general data? We have age, attrition. Attrition means that somebody left the organization, business, travel, if they usually travel, research and development, um, distance from home, education level, right? Um, education field, life sciences, others. Employee count. What is employee count? Is it like, you don't understand? They work for one person, right? So why do they have employee count? Maybe employee ID, the gender, right? Then in time, does it mean when people come and leave? So employee login time, number of employee, this is number, employee login time on the specified dates, unique value. So I don't, so what is this? This is, so they have dates. This is the date, date. And then their login time. So is this like employee ID and then this is the time they come? The guy comes to work at 10, 10, 10, 10, 9, 10. This is the time they come to work. And this is the time the person comes to work. I don't know what we are going to do with this, but I hope it is there are few days. It's as from 1st of January to 13th of January. It is not going to. It's not going to. Anyway, you'll never know. We may find value out of this. How many records are in this thing? Seems to be. We shall see. Somebody stopped coming to work. Who is this? Okay. Anyway, let's look at this. Manager survey data. Is manager also an employee? Yeah. So manager has employee ID, job involvement, performance rating. Managers have 3. I thought they would be scoring like 5. Okay, they get the average. Out time CSV. Hey, okay. So this is the time when someone leaves. Then this is the time when someone comes in. Right. This is going to be fun. Has it finished installing? It's still installing. It's saying pandas. Profiling error requirement needs job lib this, but you have job lib that. Yellow brick PyCarrect 3.4 has a requirement of NumPy this, and I will have this NumPy which is incompatible. I don't care. We shall revisit this when we have errors and we can't use PyCarrect. Then we come and go back. We uninstall, then we go back. But by now, who cares? It's our fun. It's our fun day. It's our fun. It's our fun day. And we have fun using data. So let's, this thing is not, it's taking long. So we can continue inspecting this and trying to understand. So I hope this is employee login time on specific date. I hope this is employee ID. So that if this is employee ID, we can join this data with the employee and get maybe the average time they spend at work. Yeah, for those days you can get the time they come early, the time they come late. Um, wow, stretching is nice. Yeah, so the installation is taking long. I've looked at this. What else do I need to know? The discussion. What are people saying? What is job involving? Is this real life data? Is it really? Is this real life data? Before you can post on Kaggle, you need to verify your account. um, this was originally created by IBM as synthetic dataset with 1,407. So it is synthetic data, right? So that means it is very clean. So what's the purpose of this stream? 15% attrition rate doesn't seem a problem to me. 15% attrition rate means that an employee on average stays for 6.7 years. Even Google doesn't have that kind of average. Doesn't seem real problem either. It doesn't look like a real data set to me. The data is not messy at all. Feel like it's simulated. Not sure, but I like authenticity of the scenario. Anyway, let us see. So it seems this data is not so messed up. And for us, we are looking for messed up data so that we can try. Okay, so what we're going to do is we'll try to work with this data and see how we can clean it, play with it. If we find that it is so clean, we can look for something else to do, something else to clean. What we want is to clean data, nothing else. Nothing else, nothing else we want to do. We want to clean data. Yeah, so this is taking years to install. Why? Can I hit enter here? And it looks so huge on my screen. So here's my repository. You can follow me on Twitter at Dalmas. You can follow me on LinkedIn. Please just follow the page. It's called Dali Codes. Or you can send me a connection request. There's no problem. So follow me on Twitter. Machine learning researcher, data scientist, and I am live. Also follow me on LinkedIn. Daily Codes. Sorry. Let me pull up my LinkedIn. Pull up in the gold I'm bleeding. You can follow me on LinkedIn. Has it finished? Has it completed? This installation is taking years. Next time, better. You can follow me on LinkedIn, follow me on Twitter. Daily Codes on LinkedIn. I post some stuff. I'm doing a survey currently about teachers. If you are a teacher, you can fill in this survey on LinkedIn. Yeah. Next time I will do the installations before beginning the stream. This is taking long. It's wasting some of our time. But anyway, you can take take a cup of coffee as you continue looking at this. So if it is synthetic data, it's fine. We can work with this. So I get the survey data. It has employee ID. So we're not going to do a lot with this. The first thing we're going to do is to join. So general data.csv, then manager survey data. So this manager tells us that somebody is manager or not, right? Employee ID. So everyone is a manager, really? I thought this is data for managers, but it seems to be the manager who is filling it. Yeah, you have to understand these things well. So in time, get to understand someone who has come in. So in time means what? Somebody, at what time do people come to work? This is like the barbarian way of nowadays people don't go to work. People work from anywhere, provided the job is done. That is it. We have to do work, but we don't go to work. In time, maybe if they are needed to be at work and their presence equals to work done, or their presence is needed. But for people like us who are in tech, we don't need to go to work. We can work from anywhere. Anyway, we don't mind. We are going to work with this. I hope this is, yeah, finally, installation is done. So, what do we have? We have the data. So let us launch our Jupyter Lab. And we begin playing. My Jupyter Lab has launched in a separate window. Well. Let me open it in. I don't want you here. I want you here. Jupyter Lab. Tweyaze. La 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 la. La 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 la. La 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 la. I'm going to begin a new file, and this new file, I'm going to call it file save as. Save, rename, where is rename? I am online, rename. I'm going to call it data rename lab. Let's do experiments. When we open this folder of data, these are all Excel files, are they? Or they are CSV. So one data dictionary is Excel file. Do I need it really? I can read the data dictionary from here. If I need it. So we are going to import pandas as ed. Is this clear? Let me check that. Let me look at how you see it. It's not clear. It is not clear. Let me make it bigger. I hope this is clear. Where is my OBS? I'm going to increase this to zoom. Yeah, this is clearer. I don't know if you like the dark background. You can comment. I stopped using the dark background, but it's good for my eyes. I'm going to read this data. So we begin with the first file is survey data, employee survey data. So employee survey data will be equal to pd.read.csv, and we are reading from data slash employee tab. I expected you to read it. Okay, yeah, it has come. Okay, then the second file we are going to read is general data. So I'm going to general data is going to be pd.read csv, general data. Then the next one we're going to read is manager survey, which is going to be pd.read csv. I don't know the name of these things. So this is the first one is general data.csv, but it is inside a folder called data. Then the second, this one is data slash manager survey data. Then in time, in underscore time is going to be pd.read csv in time data slash in time in underscore time .csv, then out time pd.read csv data slash out time .csv. Right. So we have all the data. Run this, then we start looking at them one by one. It's taking long. How big is it? Anyway. So I'm using Jupyter Lab. It gives me flexibility to look at the files that I'm working with here, and it has an environment that is kind of intuitive for me. I use Jupyter notebooks in Jupyter Lab environment, which is much easier and much more fun to play with. Yeah. So I'm going to look to now employee survey. Do this employee survey data.head. I want to see how it looks like. Right. So here we have employee ID, work environment satisfaction. Is employee ID unique? How do we know that it is unique? So that I know that this is just one survey, because there may be several surveys. So dot employee ID. I'm trying to find out if employee ID is unique. Finding out if employee ID in employee survey data is unique. So this employee ID dot unique. Okay. So when I find the length of that array is that. So I'm going to say this equals to the number of rows here. Dot shape. So that gives us the number of rows. If it is true, yeah. So in employee survey data, employee ID is unique. So this is one survey for each person. Great. So we can combine general data with employee survey data. So I'm going to get general data. Try to look at it. General data.head. Oh, I am blocking. Sorry. I am blocking you people. Where should I put myself? I am too big. I think I should put myself here. Up here. Yeah, up here to not block you too much. My logo. I also put it here, or I put it on my head. I put it this side. Let me put it here. So I'm not distracting here. So here we're seeing that so we have attrition, we have age, attrition, business, columns are ordered. So if I want to see dot columns do we have here? Do I have employee ID? Yes, I have employee ID. So we are going to, I'm going to combine this data. Really, do I need to? Yeah, I should. Satisfaction, environment satisfaction, job satisfaction, work-life balance with the employee ID. So let's merge this. Pandas has a merge. So I'm going to merge. It's like join, join statements in SQL. So general data dot merge. I'm going to merge with the employee survey data. I'm merging left on. So the left general data. So the general data field that we're going to use is this. And the right one is employee survey data, and we're going to merge it on employee ID. So let's do dot head just to know where we are at. Yeah, so the join, I think this thing has done full join. Let's do inner join. How equals to inner. Start of the screen. Right, so this piece of code, so we're going to, yeah, that's fine, that's fine. Yeah, so that's fine. So we're going to say the new general data is going to be the join of both of those data sets. So that was employee survey. But there is manager survey. Manager survey, I think manager survey is like a report. They just look at you and they say, guy, you have 3 for job involvement. I don't know what's the maximum for job involvement? Job involvement, let's look at it here. Job level. Job role, job involvement. 1 is low, 3 is high. So all of a sudden someone will just look at you and say, this guy has a low job involvement, and let's give them 1. Do you have people who have 1? Let's try to find those guys who have 1 job involvement. Where the job involvement, not like that, where it is equal to 1. Manager survey, underscore survey, manager survey, job involvement equals to 1. Yeah, we have them. They are don't involve themselves in the work that they do. And performance rating is kind of high. Let's look at performance rating. How does it look like? Performance rating. Performance rating is here. Also, 1 is low. So how come someone is outstanding in performance, this guy here, but his job involvement is low? Is it that they are, what's the meaning of job involvement? So job involvement level, is it like they are engaged so much at work, or they are not engaged so much at work, but their performance is high, like they have a lot of output? Can't tell it, but anyway, let's continue. So manager survey, I hope we'll not have conflicting columns. That dot columns. So here we have job satisfaction. They say that this is how their work environment is, the job satisfaction is, their work-life balance is. Then the manager looks at how they're involved at work and how they're performing. Right, so let's look at, let's merge this also. So new data dot merge. I'm going to merge it. So it's going to be huge, but who cares? Left on. So new data left on is employee ID. We're going to merge it on employee ID. Do you have employee ID? Yes. You have it here. Then we're going to write on we're going to do employee ID still. And how equals to inner. We're doing an inner join. So if you don't know inner join, outer join, left join, read about the Google joins, SQL joins, SQL joins. You can find lots of them in W3 schools, but somebody is stuck. Yeah, so we are here to solve problems. Where we are stuck is where we will learn. I am the captain. So this contains all the data for an employee, from employee survey, general data, manager data. So we are going to give this a name, all data. All data looks like that. I want it to be clear, so let me get it. You can see it. All data. Now what's remaining is in time and out time. What I don't know about in time and out time is if the ID unnamed, you see this part here that is unnamed, if unnamed is the ID. Because when we do this dot columns is the employee ID I mean. Oh wow, it has lots of days. It has 262 days. Great. What can we do with this? We also don't want to suffer curse of dimensionality when we're doing machine learning. What can we get from time? Anyway, but let's first find out in time unnamed. In time unnamed, are these employee IDs? How will we know? Let's get. I'm going to get general data dot shape. So it has, general data has 4,410. This one also has 4,410. So should it, I'm going to assume that this unnamed is the ID. So what can we do with this? What can we do with this data? It contains time, and it is a time series of the time when someone was coming to work. And you can easily tell that this person is about to leave if they start losing morale. So coming to work early means that someone has morale to work. Maybe the work environment is not toxic. And then when someone is coming late, maybe they have problems at home, or there is problem at work, or there is something wrong somewhere, and so uh, um, can we like can we no we can get the average time spent at work every day. And how will that help us? That will give us a time series, um, and that time series can help us to, yeah, so because somebody may come late but may also leave late, but the work environment, um, yeah, I think, so this feature engineering, we are going to play with it. um, this is going to be interesting. Interestment. What will I do with this data? Mm, any suggestions on the stream? Do I have anyone watching? What's my life? This is where my life has brought me. No suggestion on the stream. Um, what can I do with this? Mm, mm. Um, anyway, let's continue with this first. This is going to give us a lot of trouble, but I feel like let's play with it. So we're going to, what will I be looking for? I'll be looking at the time someone spends at work. Is it 4 hours? Is it 5 hours? So in time, out time. Then I look at that time and I play with the distribution. The maximum time someone spends at work, the minimum time someone spends at work, the the median time, or the quartile, like the first quartile, the second quartile, the third quartile. Yeah, so if someone starts slowing down at work, that means that the first quartile will be huge, will be very far from the minimum. Um, But we can also look at the trend from when someone started coming in. So let's work with this. We are going to find a way. So the first things is I want summary statistics for each individual. That is the maximum, the minimum, and then I may also want summary statistics for the, because I can't tell, you know, when we look at the attrition here in general data, when we look at the attrition here, we don't have the date of attrition. So here it is saying yes, but we don't have the date, because if we had the date of attrition, we could look at the trend of maybe 1 month before then, how was the person behaving in terms of coming to work and leaving work, or looking at their satisfaction level by that time. But this looks like, even though it is synthetic data, it looks like it is data in general. So I can't do time series because it is not we can't tell on attrition level when somebody left work. Can we? Can we? If we look here and time in is empty, is null. No, maybe somebody was just sick. So we can't tell. So what I'm going to do is just look for summary statistics. That is minimum, maximum, time someone has spent at work, the average time someone spends at work. So the maximum is going to define the outlier, the model time, yes, even the model time, so that we know just summary statistics. Anyway, let's continue with the time. So the in time and the out time. Which algorithm are we going to use to do this? I think in time and out time is the same. In time and out time is the same. So 2015 first, is it also having the same number of columns? Shape, and it's on that shape. The same number of columns. So we can just say time columns will be equal to, we pick one of them, this one, dot columns, I'll just make them a list. I want to work with lists. How does this look like? Voila. So for each column, for each person, then so we are going to have that. Then we are going to look for employee ID. Employee ID, I'm going to pick that from, since this is the new general all data, let's pick it from all data dot employee ID dot values. I want to work with lists. So values gives me, it changes this from pandas series to a numpy array. So how does this look like? That is an error. Did I do head? This is crazy. Run this, run that, run that, run that, run that, run that. Voila. So I have all employee IDs here. Now what I'm going to do is, for an employee ID, I'm going to iterate through the columns and I get the list of time. I get the time and then I calculate the time in and the time out. So for an employee, get then you for an employee I look day by day and I get time in, time out, and I get the difference. Yes, so the first thing is get time in, time out for a particular person. So time in is this. I'm going to get time in for employee 1. So time in where unnamed 0, time in where that unnamed 0 equals to employee ID 1. So I have that row. Then for that row, I am going to pick the first column, and the first column is going to be none. Let me pick this one that has a value. Pick this first value. Voila, dot values. I want the value itself. Yes, so we have this. So that is for this date, employee ID 1, and this is now time in, right? Then time out is going to be out time, the same thing, but not in time, it should be now out time. I hope it works. So we have now two things. We have time in and we have time out. So the time out is always greater than the time in. I want to get time out minus time in difference. So how do we convert this to date time? From date time import date time. Okay, so I don't know how to convert this. Convert string to date time Python. Converting a string to date time data camp. Will this work? I want date and time. In fact, I want time, but somebody may come to work in the morning or the Sunday and leaves work on Tuesday in the evening. Most of the CEOs. So how do we convert string to date time? Converting string to date time, Stack Overflow. So this datetime object, datetime.time, this is what we have, but what we have the other side is somewhat different. But let's try this. From datetime, import datetime. What is this datetime object? This. Can I like subtract this from there? Will it give me control paste and this time delta is a great can you convert time delta to a number, an integer? Because what I want is time in, time out minus time in. I want to put this time out. It is in this format, string. Then this is percentage year minus percentage month, is month capital M, minus percentage day. It's confusing. What is BD? I have to sit here. You can't sit here. Okay, so here we have so June is a month, it is B. Then this is D. This is Y. Okay. I'm going to have the time out, which, so we have the year comes first, then the month, then the day, but they're separated with the minus space. Then we have, I don't know this, space, percentage, hour, semicolon, percent, minutes, then second. Hour, minute, second. Is it lowercase? Let's check here. So hour is capital I, minute is capital M. So we have capital I, capital M, it doesn't fit format.
This one.
Just a moment. Let's continue from there next week. Let's continue from here next week.